In this lesson, we're going to talk about the distributive law. If A, B, and C are whole numbers, then A times the quantity B plus C is equal to the quantity A times B plus the quantity A times C. And we observe the convention that we do multiplications before additions, in the absence of parentheses, of course. Okay, and here we say that A distributes over this addition. A gets multiplied by B and by C here. Okay, and this is actually very important. This shows up a lot if you have to teach algebra, for example. You will teach students to do what often goes by the name of combining like terms. For example, 2x plus 3x is 5x. That's called combining like terms. I didn't choose the name. I wouldn't choose that name. But really what's going on here is that we're using we're using the right-sided distributive law instead of the left-sided distributive law. We have an x here and an x here. So I can say that 2x plus 3x is equal to 2 plus 3 times x. The x distributes over the addition. So this is 5x. It's really just the distributive law, this so-called combining like terms. Okay, so how would you explain to your students why this is true? Why the distributive law holds? Well, you could give some examples that illustrate, but examples don't tell us that there are that there aren't counterexamples, right? We want an explanation. So here's something that you could do. Okay, here I have a number of boxes. How many boxes are there? Well, they're arranged in a rectangle, 3 deep and 1, 2, 3, 4, 5, 6, 7, 7 across. So there must be 3 times 7 boxes. But also, we could do the following thing. I'm going to divide this rectangle in 2, like that, okay? And if I had actual blocks here, I could pull these apart. Here I have a 3 by 1, 2, 3, 4, 5. A 3 by 5 group of boxes. And then over here I have a 3 by 2 group of boxes. But clearly it's the same number of boxes either way. So it must be the case that 3 times 5 plus 3 times 2 is equal to 3 times 7, and 7 is simply 5 plus 2. Okay, so we get 3 times 5 plus 3 times 2 is equal to 3 times 5 plus 2. And this is clearly perfectly general reasoning. It does not depend on any of these particular numbers we've chosen, right? You can, any product can be written as a rectangular arrangement of boxes. And any way of dividing one of the dimensions like this will give you two numbers that add up to the length of one of the dimensions, and it will illustrate why this has to be true. So this is the sort of explanation that you could easily give to elementary schoolers. And they may not immediately see the purpose of either the distributive law or of the explanation, but it's very important to get them accustomed to thinking that all mathematical claims we make need to have an explanation attached to them. Right? There are no stone tablets in mathematics, right? There are no rules from on high. We all can have the authority to understand completely what we're doing, and that's one of the things that's so great about mathematics.